So in this video, we're gonna continue graphing sine and cosine functions, but in this time, instead of the period being changed, what's gonna happen is that we're gonna shift the entire curve. So now you're gonna have a plus c or a minus c. Okay, so you're gonna have a kind of like a little phase shift. Um, so these problems can be really tricky because you need to know how to add and subtract fractions, okay? Luckily, if you have the TI-36X, you'll be able to add them fairly simple. If you have a different type of calculator, they might be a little bit difficult. So you need to know how to add these fractions. I don't want to see decimals. So make sure that you give me pi over 4, for example. So if we were trying to find pi over 4, make sure that you give me pi over 4 as a unit, not 0.785, okay? So the way that that I like to find the period, or where exactly the period is basically starting off with where this inequality, at least. So 0 is less than or equal to x, less than or equal to 2 pi, which is basically symbolizing that one full period is there. Okay, so the inside of the sine and the cosine function, okay, so this inside part, this x minus c, okay, is basically what we call the argument. Okay, so the argument of the cosine or the sine. So basically, whatever that is, you're going to plug in the inside. And what you're going to do is you're going to solve for x. Okay, and that will tell you where the new interval of the period is. Okay, now the reason why I'm doing this is because later on we're going to have a b in front of the x, and then it's going to be really difficult to do. Okay, so now if you've taken trigonometry before, your other instructors might have taught you differently. There's many different ways that you can graph sine and cosine functions. But I feel like after many years of teaching this class, I feel like this is probably one way that the students like the most. So I'm going to teach it this way. So, but it's subject to change depending on what class you're taking. And also, if you take pre-calculus, your teacher might teach you a little bit differently. But just let them know that you know this type of this method, and you can ask them if that's okay with them for you to use. So here I gave you guys a couple of steps. So if you have a c being shifted, a c value like this, and you're shifting the sine and the cosine function, all you got to do is set up this inequality first. Put whatever the argument is of the cosine and the sine into the value of x. Solve the inequality for x. That's going to be step 3. And then whatever your endpoints are, so this guy, these guys, that's where the new period is at. To find intermediate points, okay, because you know that they're not going to be where they're at, remember that you're going to add the endpoints and divide it by 2, okay, until you have 5 total. Well, 3 points in the middle, and then you have 2 points on the outside, which equals 5 points, okay? You can also use graph transformations, which is basically shifting it left 2 units, shifting it right 2 units. It's really up to you. But the way that I'm going to do it is using this method. If you want to use this method and if you know it very well, you can do it. But I'm mainly going to be using this tool for doing phase shifts as well when we get to the next, and for the next couple of, when you have a B and a C, okay? So let's start off with this example. So graph the following for one period and give the domain and the range, okay? So the first thing that you see is that there's a shift, okay? So basically what this pi is doing is that you're shifting it pi units, okay? So it's not going to be from 0 to 2 pi anymore. I'm shifting the whole thing pi units over. So where is going to be the new period? So the way that I like to do it is that I like to do 0 less than or equal to x less than or equal to 2 pi. That's where one period lies. Okay, so now what I'm going to do is I'm going to plug in the argument that's in the inside into the x. So I'm going to have x minus pi in the inside. And on the outside, nothing has changed. It's still going to be from 0 to 2 pi. Then what I'm going to do is I'm going to add pi because I got to solve for x. So I'm going to add pi to all 3 sides. So you have x less than or equal to pi over here, and then over here, 3 pi. Okay, So that means that your period or this endpoints are going to be between pi and 3 pi. So when I graph this graph is no longer going to start at 0. Now it's going to start at pi and it's going to end at 3 pi. And that kind of makes sense because if you started off at 0 and I shifted over pi units, then I should be at pi now, okay? So now let's try to figure out the midpoints. So halfway between 3 pi and pi. So halfway between, so I'm going to take the midpoint, 3 pi plus pi divided by 2. That's going to give me 4 pi over 2, which gives me 2 pi. So 2 pi is going to be right in the middle. Okay, now let's think about what number will lie between pi and 2 pi. So if I take pi, add it to 2 pi divided by 2, that's going to give me 3 pi over 2. Okay, so 3 pi over 2 is right here. Okay, and then the last one, let me choose orange. We're going to look at 2 pi and we're going to look at 3 pi. So 2 pi plus 3 pi, and then we're going to divide it by 2. That's going to give me 5 pi over 2. So this guy's going to be 5 pi over 2. So that's basically where the new cycle is going to be at. So notice here that there's no amplitude change. So still from 1 to -1. Now we're not starting at 0 anymore. My new period or my new end cycle is now between pi and 3 pi. So at pi, pi is my new 0. So remember, cosine starts at 1. So we're going to start at 1, then 0, then -1, 0, then 1. So my new graph looks something like this. So that's what that looks like. Okay, so a little bit more work, but it's still doable. Okay, so when you're shifting it, horizontal shifts. Okay, now what happens if I add pi over 2? What's going to happen? So what we're going to do is do exactly the same thing. Start off where one cycle is at for sine, just from 0 to 2 pi. I'm going to put the argument inside the x, so it's going to be x plus pi over 2. That's going to be between 0 and 2 pi. And then I'm going to subtract by pi over 2. So this guy's going to be -pi over 2. This guy's going to be x. And then here what we're going to do is we're going to take 2 pi, subtract it by pi over 2. Okay, and what we're going to get is 3 pi over 2. Okay. So this is where the new cycle is at. Okay, so originally it was at 0 to 2 pi. When we added pi over 2, we actually are now at -pi over 2 and 3 pi over 2. Okay, so let's start by graphing it. Okay, so I'm going to extend now to the negative side. So we have -pi over 2 out here, and then we have 3 pi over 2 out here. Okay. So now all we got to do is try to figure out where all my midpoints are at. Okay, let me make this a little further away. I feel like I'm not going to have enough space. Okay, so the first thing to do is try to figure out where exactly the midpoint is going to be. So I'm going to choose these two numbers, and I'm going to add them and divide by 2. Okay, so 3 pi over 2 plus this -pi over 2 divided by 2. This is going to give me 2 pi over 2 divided by 2. That's going to give me just, what is this, pi over 2. So halfway between that and that is going to be pi over 2. Halfway. Okay, now what we're going to look at now -pi over 2 and pi over 2. That one's kind of obvious, right? Midway between that is just 0. So that one's kind of obvious. You can do the math if you want to, but you can kind of see that midway between the negative and a positive of the same number will be 0. And now finally we got to look at the pi over 2 and the 3 pi over 2. So pi over 2 plus 3 pi over 2 divided by 2. The top part is going to give me 4 pi over 2, which is 2 pi, divided by 2, which gives me pi. Okay. All right, now let's remember what sine looks like. So sine starts at 0. Okay, then it's going to go up to 1. So notice that there's no amplitude, or there's no increase of the amplitude. So it's between -1 and 1. So this goes to 1. Then after that is 0, -1, 0. So then here's my sine curve. And if you look at this, it looks very much like the cosine curve. And actually, you'll notice that this actually is the cosine curve. When I shift it over pi over 2 units, I actually now have the cosine curve, okay? Which is pretty cool, okay? So you can kind of already see that there's some relationship between the sine and the cosine curve, okay? Now, we're going to include this next thing in this video, which is now the vertical shifts, which is basically what happens if I add a d on the outside. Okay, what happens if I do that? So what happens is that, remember that if you add d, you're going to shift up d units. And if you subtract by d, you're going to shift down d units. Okay, so basically, let's look at what's going to happen here. So you have the sine function and you're adding 3. So if we think about the sine function, we know what the sine function looks like. 0 pi over 2 pi 3 pi over 2 and then 2 pi. If you're adding so first we're going to start off with the amplitude, so it's just 1 and -1. The sine curve starts at 0, so this is the original sine curve. So the original sine curve looks something like this. And now what we're going to do is we're going to shift it up 3 units. So we're going to shift up 3 units. So that means all of these things, all of these points are going to be shifted up 3 units. Okay, so what is this going to look like now? So maybe I should make it like this. Oh God, it won't erase. Okay, perfect. Okay, so maybe I should do it like this. So notice that there's nothing going on inside the x's. The x's are all nice. It's still going to be 0, pi over 2, pi, 3 pi over 2, and then 2 pi. And I'm going to shift everything 3 units. So this guy's at 0. Now it's going to be at 3. 1, 2, 3. This guy is at 1. It's going to go shift it up 3. That's going to be at 4. Okay. This guy is at 0. It's going to be back at 3. So the number at 3 pi over 2 is at -1. Shifted up 3 is going to be at 2. And then finally 2 pi shifted up 3 is going to be back at 3. So basically you have this sine curve now floating up in the air. Okay, so that's basically what it looks like. Okay, notice that the amplitude is still 1, because if I look at the midline, midway between it, you can see that the amplitude is still 1 unit. So nothing has changed. Okay, and now we want the domain and the range. So the domain, remember, is still the same, always going to be the same regardless of whatever you do. Now the range in this case is different, because now what is the lowest value, lowest y value? The lowest y value now is this guy, which in this case corresponds with this 2. So the lowest one is going to be 2. And the highest one now is going to be this guy, which is going to be this 4. And they're both included. So the range here is being changed. Okay? And now let's do this last problem. Y equals cosine of x minus 2. So let's start off with the cosine curve. So 0, pi over 2, pi, 3 pi over 2, 2 pi. So you're going to, the amplitude is 1, -1. Cosine starts at 1. So your graph kind of looks like this. Okay, if I draw it correctly. And then you can see what this -2 is doing right here is that it's shifting down 2 units. Shift down 2 units. Okay, so that means that this graph is not going to go downward. Okay, so instead of 1, previously was at 1. Now it's going to be now at, shifting it down 2 units is now going to be a negative 1. Okay. This pi over 2, at pi over 2, shifted down 2 units, is going to be now at negative 2. At pi, you can see that originally it was at negative 1, shifted down 2 units, it'll be now at negative 3. At 3 pi over 2, you can see that if I shift this 2 units down, it'll be at negative 2. And then at 2 pi, which is right here, shifted down 2 units, will be at negative 1. So you can see that the graph kind of looks like this. Oh God. Okay. So here, remember that the domain is still going to be all real numbers, negative infinity to positive infinity. And now the range, let's think of what the lowest y value is. The lowest y value in this case is going to be this minus 3. Right? You can see that this minus 3 is the lowest y value. So it's going to be this negative 3. And the highest y value is going to be this negative 1. And it's also included. Oh, and now the orange wants to appear. Okay, so this will be the domain and the range, and this will be your graph. Okay, so in the next video, we're going to do problems that are a little bit more complicated.